Good afternoon, students. Uh, Today morning we have discussed about general considerations in machine design. Okay, so now let's start our next point, that is types of load. So in exam a question may be asked, state four types of load acting on machine element. Only states. Okay, but for your kind information, you know the definitions and examples of these types. So basically, what is load? So load acting on a body is defined as the combined effect of all externally applied forces on a body at a time. Okay, means the combined effect of all externally applied forces on body is known as load. So load acting on a member can be classified one by one. First, dead or steady load. So dead or steady load means it is gradually applied load which does not change in magnitude and direction or point of application with respect to time. So dead or steady load means it can be force, torque or twisting moment, bending moment or combination of these. So best example of these load acting on a column or strut. Okay. Then second, variable or fluctuating load. So it varies in magnitude, direction or point of application with respect to the time. Means the magnitude of acting load may be vary. Okay. So it is also called as fatigue load. So the best example of these load are forces in IC engine, wall spring, bending moment on rotating shaft. Okay, means the bending moment on rotating shaft is should be vary. Third is impact load. So as the name is suggest impact, so it is suddenly applied with initial velocity. Okay, means suppose you have do impact on one plane, what should happen? Okay, it is suddenly applied with some initial velocity. Okay, the example is blows of hammer. Okay, and fourth is shock load. So shock load, it is sudden applied or removed suddenly. Okay, means while driving in any automobile, you should see in leaf spring. Okay, so leaf spring of automobile do that function of shock load. Okay, then next point is stress and strain. Okay, stress and strain. So what is stress? Basically these are the basics you have already teach in your strength of material. So just revise of stress and strain. So stress is defined as the internal resistive force per unit cross sectional area of body when subjected to the external load. And you may know that stress is nothing but the force upon area or load acting on body to the cross section area. So load is in Newton and cross sectional area in mm square. So the SI unit of stress is Newton per mm square. Newton per mm square. So for your kind information, note that 1 MPa is equal to 1 Newton per mm square. Then 1 kilopascal is equal to 1 into 10 raised to 3 Newton per meter square, or 1 into 10 raised to minus 3 MPa, or 1 into 10 raised to minus 3 Newton per mm square. So like that 1 GPa is equal to 1 into 10 raised to 9 Newton per meter square, or 1 into 10 raised to 3 MPa, or 1 into 10 raised to 3 Newton per mm square. Is that clear? So next is strain. So what is strain? The strain is defined as the ratio of change in length to the original length. Means change in the ratio of change in dimension to the original dimension of body subjected to the external loads. Okay, so basically linear strain is denoted by small letter e, and lateral strain is denoted by EL.